the event tonight is to bring scientists and activists and civic leaders together to help build the campaign to decarbonize North Carolina and the nation, and to require the largest polluting utility in the U.S. to help slow the climate crisis instead of continuing to make it worse. And I will introduce briefly Bob Howarth of Cornell.
Thank you. I'm Bob Howarth. I'm a professor at Cornell University, Earth system scientist. I've worked on aspects of global change for most of my career, and for many of the last 6 or 7 years, I've worked on methane and global warming. I'm really pleased to be here in North Carolina today to talk about the importance of methane in global warming and to help people realize we need to get rid of natural gas, shale gas, and move towards other energy futures. Shale gas is widely promoted as a bridge fuel. More and more of the natural gas in the United States comes from shale. And it is true that we have fewer carbon dioxide emissions from using natural gas than from coal or oil. So that's good. It allows us to get rid of coal, reduce our carbon dioxide emissions. But that idea of a bridge fuel has been very much oversold, and the Achilles heel of it is that natural gas is mostly methane. Methane is an incredibly potent greenhouse gas. It's more than 100 times more powerful than carbon dioxide for the time that they're both in the atmosphere. And as we increasingly get our natural gas from shale, those methane emissions have risen dramatically. So we have produced the first ever, as of 5 years ago, peer-reviewed assessment of what the true greenhouse gas footprint of shale gas looks like when you include methane. We spurred a lot of research, which has happened since then, more people measuring methane emissions, thinking about what it means. And in fact, we understated the problem for methane and shale gas in our initial work. It's quite clear now that the methane emissions from shale gas are very large. And when you consider those as well as carbon dioxide emissions, the total greenhouse gas footprint of shale gas is at least twice as bad as that of coal. One other underappreciated point, I was lucky to be a delegate to the United Nations COP21 conference in Paris a few months ago in December. And out of there, the nations of the world said we need to keep the planet well below 2 degrees Celsius, and that really anything above 1.5 degrees Celsius is dangerous. Well, we're on a trajectory to reach those temperatures, 12 degrees and about 1.5 degrees rather in 12 years from now, 2 degrees in about 35 years from now. And it turns out that because of lags in the climate system, there is no way to not reach those targets simply by reducing carbon dioxide emissions. No matter what we do with carbon dioxide, if we concentrate only on that gas, we'll reach those dangerous temperatures. On the other hand, the climate responds very quickly to methane. And if we reduce our methane emissions now, we'll slow the rate of global warming now. And in fact, that is the only way we're going to meet those COP21 targets. So we need to reduce methane as well as carbon dioxide. And natural gas industry is the largest source of methane in the United States. Shale gas has aggravated that. So we need to stop this idea of natural gas as a bridge fuel. It's a false promise. We need to move to renewable energy as quickly as we can. I'm very pleased to be able to deliver that message in North Carolina because Duke Energy here really needs to get that message, and your community needs to help them see that. So, thank you.
I'm David Hughes. I'm an earth scientist who's studied unconventional oil and gas and coal for the last 40 years, including 32 years with the Geological Survey of Canada. I've studied all of the major shale plays in the U.S. and published a report in late 2014. Basically, that report looked at all of the well-by-well production data with a view of looking at the long-term sustainability of shale gas and tight oil. Shale gas and tight oil have been a true game changer based on the combined technologies of horizontal drilling and high volume hydraulic fracking. And it's gone from essentially less than 5% of US gas production to more than 50% over a period of about a decade, which is remarkable. However, if you actually look at those major shale plays, you see several characteristics that really cause us to question their long-term production potential. The first is they're subdivided into core areas or sweet spots, which are much higher quality, much more productive than the rest of the plays. Typically, those sweet spots are 10 to 20% of the play area. The well declines, the production declines in the average well are very high, typically between 80 and 85% in the first 3 years. If you look at all of the existing wells in a play, you can measure a field decline of typically between 30 and 40% per year. So 30 to 40% of production has to be replaced by new drilling every year in order to keep production flat. Right now, with the price of gas being so low, companies are drilling their very best wells. And as a rule of thumb, companies always drill their best locations first. So we're consuming the very best parts of these plays, selling that gas into a very low price market. Companies are suffering. Many smaller companies are looking at bankruptcy this year. They just can't produce that gas at a profit. However, there's only so many places to drill. If you look at some of the sweet spots in the Marcellus, for example, already at a well density of 6 to 8 wells per square mile, and that's just about the max. So what this tells you is in the longer term, even looking out 3 or 4 years, when prices ultimately must rise, drilling will have to move into lower quality parts of those plays, and you'll need considerably higher prices. Conventional wisdom has it that gas will be cheap for the foreseeable future and production will keep rising. But the geological fundamentals of those plays tell you something completely different. Prices are going to have to go up. There's going to have to be a lot more wells drilled in order to maintain production or even stem production declines. And this is a story that's not being told if you look at government forecasts, which basically tell a story of cheap, abundant gas as far as the eye can see. And that's why there is such enthusiasm by some utilities to move from coal to gas rather than looking at other things like alternative energy and renewables, because they're assured of cheap gas in the long term. And I'm pleased to be here tonight to set the record straight from my geological analysis of the place. Thank you.
Good evening. I'm Rev Dr Rodney Sadler, and I am not a scientist, but a theologian. And I come here with a text from Scripture. From the 24th Psalm, it says that the earth is the Lord's, and the fullness thereof, the world and they that dwell therein. In essence, what I want to say is that this conversation that we're having today is not just about science. It's also about morality. Is it right to allow our climate to change in ways that will imperil the population and imperil first the people who have less to do with the climate change that we're talking about? We talked about the way that carbon-based emissions can perpetuate carbon change, the desire to shift towards cleaner renewable energy, but with the bridge being methane gas-based energy suppliers. And we find that that won't be sustainable, that that will cause even more harm to our environment. How do we begin to make a shift that moves towards a cleaner and greener world, a better world that will lift up all people? That's the challenge today. So again, this is not just a scientific issue, it is a moral issue. How do we make sure that we do not harm those people who are most vulnerable in this? I work with a couple of groups here in the state of North Carolina, the North Carolina NAACP, and also the Justice Action Mobilization Network. And I want to just present to you 5 different moral principles that I think will help us as we think about what we need to do with this work. The first point is that every human being is inherently valuable and deserves agency in the redemption of our imperiled planet. This is not just the work of the wealthy or the whitest among us. This is everybody's work. We all have a part to play in this. Point 2, every human being has a role to play in this work, for the planet belongs to no single color or type or creed of people. In essence, it's not only that we have a stake in this, a part of the table, but we have a responsibility to play as each and every individual, each and every group on this planet in making sure that global climate change does not imperil our planet. Point 3, the Earth really does belong equally to all of us. It's not more to Duke Energy or more to the big coal corporations. It belongs to all of us. So we must all be considered in the equation about what happens with our planet. Point 4, our efforts to save the planet can foster a better world, featuring a new relationship between people groups and between people and the planet. My suggestion is that we move from our current model, which allows for the individual ownership or the private corporate ownership of our energy supply sources, towards a larger vision, which is renewable based upon solar energy, based upon wind energy, based upon hydroelectric energy, all of which God freely gives. Instead of raping the planet, taking from the planet, we are receiving freely from that which God gives us inherently. And finally, point 5, poverty, deprivation, tyranny, and racial disparity are evils that we need to address in our collective work of reversing global climate change. In essence, the work that we're trying to do should fuse all of our efforts. We don't want to just save the world as it is with the current imbalances. We want to save a better world, a world where everyone can be treated equally, everyone has a stake, and no one ends up suffering unduly. Again, I'm Rodney Sadler, and I want to emphasize the point, we need all of us in this effort because this truly is a moral issue.
My name is Bill Powers. I'm a consulting engineer, energy engineer, and author of reports on utilizing local clean energy as our primary mode of energy supply going forward. And I often worked as an expert witness in commission proceedings and other venues where utilities put forth their vision of the future. And my primary message is that local clean energy, especially local solar power, is ready for prime time throughout the United States. And it's ready for prime time for several reasons. One is, as a result of spectacular drops in the cost of solar power, it can compete economically, it provides energy security by being locally available, and it's completely clean. What I have found is that electric utilities are playing really from the same playbook throughout the country, that we have to put in place now a massive amount of conventional infrastructure in the form of new gas-fired power plants, new transmission lines, to set the table for the clean energy future. And that I see as a self-serving and very short-sighted approach to a critical problem. And that if these institutional blocks are removed, meaning the short-sighted, shareholder-motivated plan to put in the conventional infrastructure, and the relative, the supportive stance taken by utility commissions around the country for this short-sighted approach, if those institutional blocks can be removed, we can move very rapidly and seamlessly to deal with the climate challenge. Thank you.